We've been testing laser welders here for over a year now, and shopping for one of these machines feels a lot like a shootout in the Wild West. Pew, 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 pew. Really cool material handling setup here. Half the companies don't even use their own product, and the other half aren't even manufacturers. They're known as integrators in the industry. They buy cheap parts from 10 different places, slap them in a sheet metal box, and spend a bunch of money on paid ads on your Instagram feed. Then you have the goon on Facebook Marketplace that buys a pallet of machines and starts selling them right before he disappears forever, which forces a lot of people to go to Alibaba and buy the cheapest thing that they can find. But it's better than the Facebook guy. So I got really tired of guessing and wasting money on machines from all these random suppliers on the internet and decided to jump on a plane to China and find the real manufacturers. One of the big reasons I'm here is because they don't buy parts, they make their parts. Everything from scratch. Even the tips for the welders. Every single component gets made right here in their machine shop. That's the gun. That is the start of the laser welding gun. Look at that chassis, guys. CNC machine, billet aluminum?
Yeah.
Wow. Pew, 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 pew. You can make your own assumptions about Chinese manufacturing, but this is the real deal right here, guys. Because I'm not going to do business with integrators or marketing companies because they just add cost, but only to the people that are too lazy to put boots on the ground and do the actual work. I also can't sign an executive order to bypass import tariffs on laser welders like the 90-day ground beef deal. So I have to get all the way to the source, just like I did with the sheet and tube lasers, which means putting boots on the ground and spending weeks checking under the hood. We were on a mission to find the best laser welder in China this week. We got Ken right here. He's taking us to the factory, and we're gonna go see what he's got going on. I once again ran into a safety issue with that other laser welder company. They don't have the FDA certification for export to the US.
We have a special machine, this one.
Okay, so that's their filter to prevent backsplatter in there. That brings us to our first real question. What's the difference really between a manufacturer and an integrator? An integrator buys someone else's resonator, someone else's wire feeder, control board, drive rolls, gun, and puts it in a generic chassis and hopes for the best. When something breaks, they have to call 3 different suppliers to figure out why and then chase down exactly who screwed up. A true manufacturer designs and cuts their own components in-house. So when you want custom software, tighter tolerances, better ergonomic controls on the gun, they actually have the machining muscle and engineering staff to make it happen. And the only way to tell the difference is to actually go to the factory and ask to see their whole manufacturing system. Absolutely next level. Down to the reporting is automatically updated to their server. Nobody even has to put it in the box. As soon as the roamer arm finishes its inspection, it's all separated by lot numbers, and the log automatically gets made and stored. So if there's ever a problem, we can come back to the factory and they can look up that specific lot number and they can see what happened and if they need to tighten up any of their tolerances.
It's a screw nut.
Oh my gosh, micro machining, guys. I thought these were chips, bro. I thought these were... Oh, here's the chips. They're even making their own gaskets here, guys, for the machines. Let's check out how this works. Really cool material handling setup here. Upstairs is all the raw material. It gets pumped down to the machine out here in the shop, which is kind of hot. And then all the guys to work inside here, which is air conditioned. So they're feeding and operating the machines from inside this room so they don't get too hot. Ken's a pretty good boss here. Nobody even touches it. Rotates up 90 degrees, comes over here to the trimmer. What's this? Inspection camera running the whole time. That's an updated picture of all the inspection points for the screw nuts. All the batch rooms for the different plastic. The factory prepares 3 meals a day out of their kitchen and serves all the employees breakfast, lunch, and dinner. And their work day is 9 a.m. to 5:30, or no, sorry, 8 a.m. to 5:30 with an hour-and-a-half lunch. How sweet does that sound? I could go for a little nap time after lunch every day. We found the Oompa Loompa factory. Over here is the clean room where they are manufacturing the resonators, and they're splicing the fiber to the pumps. And this, what is this, final assembly?
Yeah, there is the final assembly.
So this is the steel chassis right here all lined up. And then these guys over here are doing final assembly. Better put that hairnet back on, buddy. And there's all the units ready to roll. Now, question number 2. Our old welder was a great proof of concept, but it has a major flaw. It can weld for about 5 or 6 minutes straight before the system overheats and shuts down to cool off. In a real fabrication shop, that is completely lame. Can an air-cooled laser actually run 100% of the time in your shop? Uh-oh, this looks official. This is cool. This is the load testing center, and what they do is they test every single machine for 500 hours at the highest temperature and the highest humidity that it's rated for. So they know every machine can last in the rough, dirty environment that is a metal fabrication shop. I don't know if you guys can hear me in here, but it's really hot and humid, and it's super noisy because all these are getting load tested at 100% duty cycle right now. So that's the fiber, and it's pumping into this tube right here. So when we say 100% duty cycle on the machines, we mean 100% duty cycle on the machines. Up to 500 continuous hours without a failure. So the thing's not gonna overheat. You're not gonna have to wait for it to cool down. You can just start welding and keep welding. Which one do you guys like better? This style or this style? I was thinking about your 500-hour test yesterday.
Yeah.
So that is testing the
Reliability.
the power supply though, right?
Yeah, yeah.
So with our laser welder, the one we have in the shop right now,
Yeah.
the power supply is not what overheats, it's the lens in the gun.
Yeah.
So what is the duty cycle of the gun on your machines? How long can you weld continuous?
Normally we were doing the 10,000 cycle life test for the switch of the gun.
Yeah, but that's the cycle count.
Yeah.
But what about when you're welding continuously, how long before that gun overheats?
Normally over 2 hours or something like that.
Oh, 2 hours of continuous?
Yes.
Maybe we can test that today.
Yeah.
All right. Yeah, it can, if it's engineered correctly. That means the gun, optics, and cooling system are engineered to let you pull the trigger and weld all day long without having to sit around waiting for a fan to catch up. Now, question number 3. One of the biggest criticisms I have personally with laser welding is your fit up has to be absolutely perfect. You've got to be a 16th inch or less. So the biggest thing I was looking for, honestly, on this trip is a machine that can bridge bigger gaps. What's the biggest gap you can actually bridge effectively, and what does that take to do? Because in a real world shop where you're actually cutting and fitting things up by hand, a 16th inch tolerance just isn't realistic. Yes, you could get there, but how much time and money would you spend getting to that kind of a fit up where you could save the time and money with the laser welding operation? Oh, safety interlock, 2 motions. So both together. Okay. So then you just select the okay, and then
You can even change the parameter.
okay, very cool.
Yeah.
Don't worry guys, I'm super safe out here. So we're working with them today to see how big of a gap that the machine can fill without doing any sort of whipping motion or like triggering, pulsing like you would with MIG to try and fill that gap and bridge it. What can this thing do in one pass clean? So here's my thumb for scale. Super flat. Not too shabby for a big gap there. Okay, welding the gap was cool, but it wasn't very deep. So the machine was in wide mode, and now we're gonna put it in deep mode and see if we can get that big gap filled and get more penetration and a higher deposition rate, which is what you guys are really gonna need. I wanna see if we can get this wide and deep at the same time. You know what I'm talking about. So smaller gap, but much deeper penetration on that. That pretty much went all the way through. Nice. I know you guys are familiar with the Texas TIG trick, laying some extra wire in there or laying a TIG rod down before you run a pass over it, but how much can you actually weld with the machine without doing anything fancy? We worked the engineering team to triple that number from a 1/16 gap to a 3/16 gap. The coolest thing about the laser welder and filling gaps is the wobble is built in. So everything you run with the laser welder is actually gonna be a stringer bead, and it's gonna do the weave for you and tie both sides of the apparent metal together. Which leads to the ultimate question: who actually makes the best laser welder in the world? Not the most overpriced, not the most underpriced, but the best engineered machine that will actually hold up daily in your shop. What should we test, guys? Because we aren't gonna guess based on factory brochures and spec sheets. I actually put my money where my mouth is and bought 2 of these beta testing machines to bring in the shop and run head to head. And that's gonna be the next video here on YouTube, is actually running these in a real production environment and seeing which one holds up and which one falls flat on its face. Here's our second machine. We're gonna put it up against so we've been running here for over a year in the shop. The testing process has already started, but I sincerely wanna hear from you guys. We have our list of what we think is important, but we're primarily an architectural metal shop. So we're not doing structural, we're not doing trailer repairs, we're not building farm equipment, we're not doing a lot of, stainless steel, sheet metal work. I know there's a lot of different applications for these laser welders, and I wanna know what's important to you guys. Are you guys looking for maximum penetration, maximum weld speed? Are you looking for the least amount of cleanup after your weld? Are you just trying to replace some TIG processes? Do you need a reduced heat affected zone? Are you guys welding thick, heavy plate all the time? Or is a continuous duty cycle for welding really long seams what's gonna be most important to you? Maybe you're most concerned about safety, and that's what's holding you back from welding with the laser. And we have some solutions for that on the way as well. So drop your comments down below, let me know what you guys wanna see, and I will do the testing and get back to you on what the best laser in the world is. You guys want some of this?
No, I'm good.
Ruben, you want some steak? Steven? You want some New York or some tenderloin?
Pretty tender, actually.
It's an $8 steak from HG Hill.
Fucking barbecue on a bench with a laser.
Yeah. Here's a really interesting little tidbit that the factory just told me yesterday. They said they don't sell on Alibaba because the customers there are garbage.